Greetings, everyone. Today we're going to explore linear regression. We're also going to refer to this as the line of best fit. As you can see by the image I have over here, what if I'm given a graph with a bunch of dots? I can't draw a line that'll fit all the dots, but I can draw a line that would exist in the middle or an approximation of what that line would be. We do have a foldable for this. If you don't have access, I recommend jotting this down in your notebook. Let's start with a few definitions. Scatterplot. Scatterplot is a graph that relates two different sets of data by displaying them as ordered pairs. Now, we're used to plotting points, but our points tend to make a line. Scatterplot just means we're plotting points that are scattered. Now, the data is going to be related to the real world, so maybe the x-axis is time and the y-axis is money, right? We can have those values scattered across the graph. Let's talk about what line of best fit is. A line of best fit is a straight line on a scatter plot that comes closest to all of the dots on the graph. So we're trying to find a line that best fits the data set. It's not going to touch all the dots. It can't. But it could touch some of them. It could be amongst most of them. Let's talk about the vocab word correlation. Correlation is the relationship trend found in given data. The relationship trend, meaning if I just make a general statement about what I see. So let's look at that first graph on your note sheet. It looks like this. If I asked you what the correlation is, right? If I tried to say in general what's happening here, we would say it's positive correlation. Versus this graph, if I was to try and sort of connect them or talk about them, the data is trending down. So we would say it's a negative correlation. And if there's no trend, if dots are just everywhere and they make no sense, we can say there's no correlation. Now we're going to talk about a few things. First, we're going to find the line of best fit for a set of data algebraically, just using the properties and the steps that we've already been using. So let's identify those steps. Step 1, you're going to find the slope between 2 points. We've been doing that. The difference today is we need to pick 2 points that represent the data well. Step 2, we're going to write the equation of the line. If you're not told how to write it, you can choose slope-intercept or point-slope form. Let's take a look at this example. This table shows Ariana's hourly earnings for the years 2001 to 2007. We're going to use 2 points to write an equation for the line of best fit for the data. So I don't even need to graph it, but let's just talk about it for a second. As the years increase, her wage increases. So she's like a 10, 10.50, 11, 13, 15, 15.75, 16.50. So like we've got a positive correlation going on here, right? Now, if you're given this table and the numbers are pretty close, you get to pick. So I'm going to choose the first and the last set of points to find my equation. So let's go through our steps. Step 1, I need to find slope. Slope is y minus y over x minus x. If you need more support with that, you want to see a previous video. So my first y value, I'm going to start with the largest y value, is 1650, and we're going to subtract 10 over 2007, subtract 2001. Let's calculate that. $16.50 subtract $10 leaves me with $6.50. 2007 minus 2001 leaves me with 6. I can reduce that down. That would be 1 1/2, which would be 3 halves, right? I want a nice clean slope. Use your calculator to simplify that if you're not sure. Step 2, we want to write our equation. Now I can Use either point that I used, but make sure you stick to the two that you used. And let's write point slope form. So y space equals space x space. So my slope that I found, I'm going to fill that in front of x. And for my point, it doesn't matter. I'm just going to pick the top one that I used because it's cleaner. So I'm going to say minus 10 and minus 2001. Now, if you are only asked to write a line and it doesn't tell you what kind of line, we're done. We have the equation of a line. All right, now here's where the foldable is going to be necessary. Otherwise, you have quite a bit to jot down. We're also going to explore using Desmos. And to use Desmos, we are going to enter data into a table. We're going to zoom and drag to see all the dots show up on the graph. And we're going to have Desmos tell us the equation by typing in y sub 1 squiggly m x sub 1 plus b. Then we're going to jot down the numbers we're given and write our equation. At this point, you're going to make sure to have this in front of you, and I would like you to go open Desmos in a second window. All right, so at this point, we're going to look at Desmos and example 2 at the same time. So make sure you can see your foldable, your notes, and your Desmos screen. Let's follow our steps. The first thing we want to do is go to the plus sign, and we want to add a table. In that table, we're going to enter our data set. And the example is talking about the average body temperature in degrees Celsius of 9 insects at a given temperature. Okay, so we really just want to enter all the x values and all the y values. So let's start with the x values. I see 25.7, and if you press enter, it'll just go down to the next tab. I think it's easier to enter the x values first, followed by the y values, so I can use that enter button. Let's go to the y values. 27. If it says 0.0, of course you don't need to type that. Double check your typing, make sure all the values are correct, because if one number is off, that will drastically affect your data set. All right, now if you look, I don't see those dots on my graph because they're in the 30s and 20s. So I need to zoom out or move and click and drag my graph around until I see those dots. But I also still want to see my axes. So I think this is a good picture of what I need. All right, the next step that we have, we want to click add, and we want to add an expression. So we want to start typing. If I type y and then number 1, it automatically makes it a sub 1 because it's saying, hey, that's what you labeled your table as. See how my y values are that y sub 1? We want to use squiggly. Squiggly is before the 1 on your keypad up in the top left corner. We then want m. We want x sub 1, so type x1, and it automatically makes it a sub 1. And then we always have a plus b value, right? We're literally writing y equals mx plus b, but we're telling the computer, the graph, which x and y values to use. So in this moment, I can see that I have those parameters, and I want to write my equation. All right, so I closed our graph, and using that information, those parameters, right, they said m was equal to 0.94878, 49, and the b value said 1.53247. So we're going to write our equation. So y equals, if you're told how to round, please pay attention to that. I'm going to use 3 decimals, let's say, for this. So my m is going to be 0.4949. I'm going to round up that third one because the next one is 7, right? So that rounded up. Followed by x, followed by my b value. I'm going to do 3 decimals again, 5, 3, 2. So I just created my equation. It's much more accurate than if I was to make an assumption about which 2 points are best. So make sure you're going to have some tasks on Desmos. You have access to Desmos. You can even log in using your school account so you don't lose your work in there if you want to reference back. And then also make sure that you pay attention to the directions of rounding. All right, let's approach the next example also by using Desmos. Because this is new, we need some practice. So on example 3, I'm going to click Add Table. We're going to enter our table. Now when you look at that table, the columns are just separated over, but they could have been written all together. So don't let that confuse you. We want to enter our values as accurately as possible. Make sure to take your time. So on this one, we're talking about bowling scores, and we're talking about the top 10 bowlers in a specific tournament. So we've got these scores. Again, I can't see them on my graph, so I need to zoom out. We're talking hundreds, right? Now, if you want a more specific graph, because this looks weird, let's go to the wrench, and we're going to specify our x-axis. Our x values exist. I'm going to go from like -5 to 15. Oops, -5 to 15. There, look at how those dots spread out, right? And then I'm going to go from -10 on my y-axis, and our highest score was 210, so let's say 250. So if you really want to make your graph look good, just click that wrench and enter your graph limits. All right, we want to write an equation. So let's click the plus sign again. We're going to write an expression. We're going to start with y1 because that's what my y column is listed as. If for some reason there's a 2, then do y2. Squiggly m x1 plus b. Look at that line. See how that line goes through the middle of the data? It truly shows a line of best fit. If it didn't go through the middle of the data, if it was way off, then something's going on. So now we're going to take this information and we're going to do a little more work with it. So from Desmos, we were given an m and a b value. Our m value was about -7.87273, and our b value was about 201.2. That's not too bad. So we want to write our equation. Y equals m. I'm going to use 3 decimals. I need to round this one up. X plus b. We're not done on this one. This one has a question, just like our other word problems we were doing. How many points did the 15th ranked bowler earn? Meaning if I was to continue my table using this assumption of this regression line, what would the 15th bowler's number look like? Well, we put in the ranks as our x value. So instead of x, we're going to plug in 15. We're going to use all the values given. We're going to multiply that and add that. I'm replacing the x. So here's where you can see you definitely need a calculator, don't you? So I've got 7.873 times 15. That's 118.095, negative of course, plus 201.2. Now we want to combine those values. I'm using my calculator as well. And I've got a y value of approximately 83.105. But let's look at the points. Did they do any partial points on my table? No. So let's round. It would be approximately 83 points. right? If the given table doesn't have decimals, then you don't want your final answer to have decimals, okay? You need to round according to the scenario. So again, we want to practice using Desmos. If you're not given Desmos, if, for example, on a learning check, right, you're going to pick 2 points, find the slope, write the equation like we've been doing. All right, so that was kind of a lot. So again, make sure you keep working with and trying Desmos. You are mostly, though, going to have to solve by hand. So most of the time, you're going to find slope and write your equation, typically in point slope form. Okay, and then if you're asked, you might have to use the equation to solve a question. Make sure, as always, that you check out Google Classroom to see what your task is. Let me know if you have any questions, and until next time, have a good one.